Hi, welcome back. The problem today is about the definite integral that contain the radical sine and also the trigonometric function. Now let's get started. We have the integral from 0 to pi over 2 of square root of sine x over square root of sine x plus square root of cosine x dx. So to solve this kind of the integral, we have to think about the method to solve this form. We look at on the domain of x, that's it from the 0 to pi over 2. And look at on the numerator, that is sine x, and denominator, that is sine x plus cosine x. And we can link that expression into some formula in the trigonometric function. We already know that. Based on the domain of x, we have sine x will be equal to cosine pi over 2 minus x. You see, that's pi over 2 is related to the domain of x here. And then cosine x equal to sine x sine of pi over 2 minus x. So we sum the equation here. Then we have sine x plus cosine x will be equal to sine pi over 2 minus x plus cosine pi over 2 minus x. Then we have something the same, nearly the same as the denomination, and this is about the numeration. So then we think about substitution value here. And this how we think about a substitution variable. We put t equal to pi over 2 minus x. So dt will be equal to negative dx. And domain of this will be 0 to pi over 2. Now, let's replace t into the integral I. Then we will have I will be equal to dx negative, and when x equal to 0, it means t equal to pi over 2, and when x equal to pi over 2, t will equal to 0. And square root of sine pi over 2 minus t, and on the denominator, that's sine pi over 2 minus t plus cosine pi over 2 minus t dt. Then we see this is the negative side, and this is the domain of t. When we change the position of the domain of t here, then it means we can remove the negative sign here. And we can rewrite that 0 to pi over 2. At the formula we have sine pi minus t will be equal to cosine t. Then square root of cosine t over square root of cosine t plus square root of sine t dt. And now we recognize that the domain of t is same as domain of x, and I, the interval at the beginning of the problem, equal to the square root of cosine t over square root of sine t plus square root of cosine t dt. So based on that, we can rewrite the integral of the problem like this. Square root of sine x cosine x dx, and it's also equal to square root of cosine x over square root of sine x plus square root of cosine x dx. You see that if we sum up the expression, then the value should be 1. This one, this expression, and this expression, the value should be 1. So then we have 2i will be equal to 0 to pi over 2 square root of sine x plus square root of cosine x over square root of sine x plus square root of cosine x dx equal to integral of 0 to pi over 2 dx. Then this will be x 0 pi over 2 is pi over 2. Then the final result of the interval is I equal to pi over 4. So the lesson of this problem today is just one thing. It's about consider the domain of the variable in the interval. If it's something like special from 0 to pi over 2, then we can consider this formula from the trigonometric function. And if it have the form like sinx and cosx, we obviously have to use that. So I think that's it. Thanks for watching. See you later. Bye.